everyone, and welcome! I've been super excited for this particular stream, and I see you guys are like totally pouring in, and I apologize for being a little bit late. I had quite a few mishaps. So this stream is actually turning into being like the Tenacious D movie. It's a tribute to the lighting effect. It's not the real lighting effect, it's a tribute. And then they go around the entire movie singing that song. So we're gonna do kind of the same thing with the LED lighting. I got everything done, and I was a little bit late because we had a power outage literally right before I started. We had a massive lightning storm going on, so I was like really excited, and if we have a couple residuals, we might be able to test out our lightning detector. So anyways, I had this propped up on a stool for you guys. Beautiful. I had a camera on it and everything. Then I decided it wasn't quite center enough, and I started to move the stool with this on it. And I didn't realize that the wiring got caught up on my workbench, and it went and so pulled some of the wiring in the back. Hence, I have this really fake, lame wiring strip that I just kind of laid around to mimic, you know, what this would look like. And so for our real effect, I'm gonna just switch you guys to what we got going on here. And for those of you that missed our 3D kind of theme, this went really, really well. And we had like Dave here, Gel, Robert McSween, or McSweeney, I think it's McSween, and then also Merlin giving all kinds of cool advice on tucking these in, layering it up, using Mod Podging over the little rocks so they don't fall like glitter. So I think the final product ended up looking really, really good. So let me catch up on the comments. We have Brian Palmer, hello Rachel. Dave Beck saying, wow, now that's some cool lighting effects. Well, I'm glad you like it because this is just a tribute. The real one, I'm gonna have to do a makeup stream for you guys. Give me a little time to fix the back that I botched up because I was trying to, you know, get the perfect camera angle for you guys. Frozen Mustache saying that looks awesome. Carl James is here. Say hi to your brother. Rick is here as well as Gel. Say hi to Cindy and Eric for me. And Brian Palmer's also thinking that looks awesome. So I kind of set up this lame setup right here just for us to have an idea of how the light would wash against the castle. And so the things that we're gonna have to pretend in our minds is the lightning bolt that's gonna flash up here, as well as the interior lighting. I have a little amber flickering light in here and an amber one in here. Also in here is a blue one that goes off from time to time. So we're gonna pretend that's all going on, you know, and we're gonna use this strip where I'm gonna show you how I segmented different areas of the strip to do different things, just like the strip on the back of this board. And then I'll flip the board over and show you guys the atrocity that happened back there. But I also learned a lot of things while soldering LEDs because this was my first attempt at it. The only soldering I've ever done with LEDs is just soldering on the initial little hookups here, you know, and I'll gently kind of move this. So these three, you know, I've soldered just one time, get it working. But this was a lot more intricate because we have one LED here, one here, a few here, a few here. And so I had to do a lot of cuts. Now with this, the more you cut up an LED strip and then try and tie individual LEDs together, the more possibilities for error that you have. But I wound up pretty lucky. I got this thing working until I didn't, you know. So let's get started and see kind of like some lighting effects that I thought of. And a lot of this comes from your guys' suggestions. We did a whole fast LED or fast LED library examples. You can go back to that. And we went through a ton of examples, and you guys were like, I like that one better, I like that one better. So I took your suggestions and I went ahead and incorporated. The only thing that decor-wise that I'm not too thrilled about, and I want your guys' opinion, I decided not to take it too far because I know a lot of you guys have ideas on better ways to do some of the foam miniature stuff, especially those of you that do this all the time. Now, I'm not thrilled with these 3D clouds. I thought they were gonna look like super cool. It kind of looks like cotton balls glued to the backing panel. It doesn't look bad, you know, but I kind of had higher hopes for it. It does look cool when they light up. You should have seen them when they light up, but you won't because I ruined it for you. So I'm totally willing to hear your ideas on kind of improving these. One of my ideas was to very lightly using an acrylic wash, not to douse the whole thing, but a nice wet brush, and then just kind of poke the clouds in places. Because the clouds, I think the problem is that they're just white. They're all white. And on the clouds that I painted, they're multidimensional. And I think if I would just take some grays or some dark blues and just ink wash it or acrylic wash it on certain points, that would give the clouds a more 3D and realistic look, instead of, you just glued a bunch of cotton onto your board, that type of look. So I'm hoping not to rock that look. But, so those of you guys with suggestions, I definitely wanna hear it. So Jella saying looks great. My son Eric said hi back, and also to Cindy. Dave Beck is saying you can turn on your flux capacitor and go back and prevent yourself from pulling the wires. That is actually why I put this shirt on. I was wearing a different shirt, and as soon as that happened, I didn't want to throw anything across the room or break stuff. Sometimes it feels so good to just break something when something like this happened, especially since this is so intricate, and wiring the LEDs and soldering everything was super intricate. So with all that being said, let's take a look at some of the schemes that I put together. To do that, I'm going to jump over to the computer. So for that, I'm going to put you on a quick intermission because I'm going to move this mic over there so you can actually hear me, and then we'll upload it and see how it would work. You'll see the segmentation and things. So I will be right back. All right, so we are back, and yes, we have audio. So let me show you kind of like what this is. And we already went through this, so I'm not going to go through this in a ton of detail. That video is still up, and you guys can, certainly take a look at that. Where the code, I try to keep it as simple as possible. There are much better ways to code our effects, but I figured, you know what? A step like this is a nice kind of incremental from what we did the last time, rather than taking a huge leap. Those of you that have worked with this library before know that to segment this, the best way to do it is using the sets, the CRGB sets, and then grouping everything together that way, so multiple arrays. But here we kind of individually identify things, and I'll kind of explain why as we go along. So in this code or sketch for Arduino, basically this is the scenario when there's no storm, there's no lightning. What do we want this thing to be doing, during that time? So that way it doesn't sit there dark and boring, until we have a lightning storm. So I'm just kind of keeping an eye on your comments over there. And Carl James is saying you can get a flux capacitor at O'Reilly Auto Parts. He's even got a part number. Ooh, thank you. I'm gonna look that up and head on over. So right before we were having mega lightning storms here, and we're actually gonna get a chance to for real test this out, I think, because we're getting into that season where every day now we're getting storms. It's just that late summer stormy type of weather. So we're finishing this up right on time, So let's take a quick look here. So the very first thing is just to include the library. This gives us code snippets and extra functionality that somebody has already written for us that we can tap into and grab. So here we're going to define the number of LEDs we have in our strip. So in our real case, it's 110. so it knows, what its boundaries are. Then we have to say which pin is the LED strip attached to in Arduino. So I attached it to pin number 2. And then we just kind of put our array there. And then some of this I'm going to skip. We talked about this a little bit further in the other stream, and our setup is basically it runs once just to kind of set things up as it says. So here we're just telling the Arduino what kind of strip we have. Now this is an individually addressable LED strip. That means that you can tell each LED to do something different if you want. Although that's a lot if you're doing hundreds of LEDs and each one is doing something different, but totally doable. Then which pin is it attached to? And if you see here, we had already specified LED pin is number 2, so just LED pin, and it'll go back up in the code and say, oh yeah, that's 2. And then the order of the colors, the LED colors. Now each strip is going to be different. This is the most it's the most common one. So sometimes it's RGB, BGR, GRB is pretty much the most common. And we went through a test to determine which color order your strip is in our past stream. And this is just kind of a global, what we want to set our strip to. Now, if you set it all the way high, well, that's going to up your power consumption. So I've always had good results with 50. You saw it's pretty nice. It's pretty bright and gives you something nice. So it's nice to just kind of set it globally, and then you can always change it down the line. So here's our loop. And in our loop, it basically repeats. Everything that comes after here repeats, and then it goes back to the top and repeats again, and it just goes on forever. So here I'm telling it that every 100 milliseconds, I want you to take the very first LED, which is called LED 0. I mean, I wish it was called LED 1, wouldn't that make sense? But no, it's LED 0. And I wanted to have a color, and this is HSV colors. And we spent a whole bunch of time talking about RGB versus HSV versus just saying red, and just the more common color names. So 32 is kind of like an orange amber. And then 255, this area is the saturation. So how saturated do we want the color? Do we want it like really amber and orange all the way? Or if you turn that down to 0, you lose all the color data. So then that in essence makes it white. And then for the value, how bright do you want it? So saturation is how much color pigmentation do you want, in other words. And this is how bright. So it's like a dimmer switch. You can set it all the way up to 255, which is all the way, or 0, which turns it off. For us, because we want to randomize this a little bit, because if you recall, and I'm going to write myself a note here. Usually I like to, write notes because I do make this available to you guys so you guys can download and play with it. So this is the kind of like interior lighting right here. And I use these 2 slashes because the code ignores, stuff that comes after it on the same line. And then Mick Perkins is here. Glad to be here. For some reason, your video is only 2 by 2 inches rather than the usual full screen. Yes, you're probably talking about this tiny little video I have here. It's just to give us more screen size. When I put the big video on, it kind of covered a lot of things. But when we get back to the project table, I'll be full size, I promise. I'll be totally full size. So I'm miniaturized now so you can see the code. And in order to make the code a little more visible, because I'm looking at it and I'm like, man, let's make it like maybe 24 font. There we go. So that makes it a little bit easier for our eyes. So anyways, this block of code here talks about the interior of the castle. So LED 1, that's the one that is inside Frankenstein's tower, his laboratory. So we're setting that to the amber, and we talked about the rest of the numbers. Now this one, I also want to set to amber, which LED number 1 is actually the Tesla one, and we're going to get to that. That's a little spark that goes off in the laboratory from time to time. So here we have Frau Blücher's. Frau Blücher's LED. And so again, it's set to that amber. We want it to be its full amberness in terms of color pigmentation. And we want to randomize the dimmer switch. So that way, every time this thing runs, it kind of picks a different brightness, kind of like a candle. And it's going to change that every 100 milliseconds. And same thing for LED 3. Now, this is the LED that's located in the tall tower in the back of the building. And I'll show you guys all this stuff. Same thing, we want it amber, full amberness, and we want to randomize the brightness level. So that way it's like a dimmer switch. So this is all to simulate candle flickering. Now, there is specific candle flickering code out there on the net. In fact, there's some on Discord. I think Dave found some really great code that he posted. But because we're only doing 3 LEDs, I kept it simple. I just specified each LED. Now, can you imagine if you're doing an entire strip of hundreds of LEDs? You do not want to individually specify this stuff. That's where the sets come in. And so that's kind of like a bigger jump. Eventually, I'm going to transition all this code into that, and then that code will be available probably at the very tail end of this project when we start adding other things in the background. Then this code basically says, turn on, so you tell it what you want it to do, and this is pretty much, okay, activate what you just said, so it means turn it all on for those that you specified. So then right here, I'll make a note to myself, this is the spark. The spark is basically also in Frankenstein Castle's tower, in his laboratory tower, and I'm saying every 5 seconds, just kind of turn it on, and so LED 1, we set it to 160. 160 is kind of like a nice bright blue, but not like too dark blue. It's an aqua-ish, it's probably the closest to a Tesla coil color that I could think of. We also want this full brightness, and when it turns on, it also will just pick a random, a random value. So every 5 seconds, it changes this value. So it just looks like there's something going on back there, experimentation, wise. And then we get into this code, and basically we've already talked about LED 0, 2, 3. Now I'm jumping to LED 40 because we're jumping past the clouds and the thunderclouds and the lightning. And this is kind of the sky. I wanted to come up with cool lighting for the sky, a lot like you saw, and it's all going crazy right now, but something to wash over the castle, and maybe it changes over time. Jill said, I got you on my 60-inch TV. Harry Graham is here. Hi, Rachel. And then David Beck is are those shrimps? No, those are horses. Those are horses because I'm looking from afar. So, there we go. That's much better. So in this code, we're basically saying, we're saying that the integer I equals 40. That's basically like start at LED number 40, and that's where my sky starts. And we're gonna go from 40 all the way up until 109, which is the very last LED in the thing, in this whole entire project. So then it's going to increment from 40 to 105 or 109. So you can see that, we said I equals 40. So you might as well, it's like putting 40, right there. And it's going to go up to 109 and increment by 1 every time. So basically we want, we're using the hue value, which is how we used all of these up in here. And there's basically a chart online where you can say, I want to make these LEDs pink. And you can go and look up the hue value, and you're like, oh, okay, pink is, 200 something. 255 is red. 0 is also red. Very close colors. And it goes from 0 to 255 and then cycles back to 0 to 255. So it's cyclical like that. Anyways, so whatever hue we pick, we want to make it full colorness, full pigmentation and full brightness. And then here I'm telling it that every 1,000 milliseconds, increase the hue by 1. So it's going to go from 0 to 255 every 100 milliseconds. So 100 milliseconds, 2, and it's going to cycle through 255 times. In essence, what you're doing is creating a rainbow effect, and this rainbow is going to wash over the castle because the rainbow is kind of like what you guys like the best. So you guys picked this one. So those are the essence, numbers of the code. And if this is something you're interested in learning, but you're like, I don't want to learn how to do any code, just like give me the strip, I'll wire it up, and just give me some code. If you watch our tutorial on this library, I tell you exactly where you need to change the numbers and what to change them to. You don't even have to know the code. Just like pick where I went and then change them. And we give you several examples like gradients, chasers, all kinds of things. You have to know no code. Just like, you know, go to the little parameters I show you and you'll be fine. So what I'm gonna do now is head on back and put you guys on intermission again. It's you know, kind of annoying. I need some kind of like a 2-for-1 type of situation and put, you know, multiple monitors and a computer that comes down out of the ceiling. And I'm gonna upload this code from my laptop, and we'll see what it looks like, you know? So I'll see you guys soon. Sorry about that. There we go. We got audio now. So sorry about that, but I think I heard some lightning. Now, I don't know if it's somebody dragging in the trash, but it might be lightning. So let's hurry up with this so we can get to testing. So I have my laptop down here. And so this is running on some previous code right here, and I'm going to do this. So we see it together, what this is. And of course, we're gonna use our imagination a little bit because I totally screwed this up for you guys. So I'm just logging in here and grabbing, it's like I have a secret laptop here. And let's see, not that one. Let's pick the right one because that would help us. And let me open it up. And which one? This one. And I'm going to upload it. And you see it kind of froze a little bit. It's thinking about what's going on. And why is it? Oh, it's freaking out. It is freaking out. Let me make sure I got the right one. Hold up. Oh, I might have pulled up the wrong one. Let's see here. Got that. Ooh, there's an error. Let me fix it. No wonder. No wonder. And when we get back to the computer, I'll show you the boo-boo that I did. So you can see that I am like super prepared. This was all tested out beforehand. As a nut. That's why we end up like spontaneously fixing things. All right, let's see what that does. Let me check and make sure that it is good. All right, I kind of like that rainbow effect though. That was kind of like a Bob Ross unexpected mistake. All right. Now that is going crazy too. Let me just make sure I have the right file here. That one. This is the test number 2. Bear with me, people. Bear with me a sec. All right. So, test. Yep, it is this one. So, let's see here. Why are you being funky? My rainbow effect is not working right. Oh, that would be why. wondering if this was like an old file and I only have the new one over there. So let's see here. There's a couple things that are missing that I'm fixing as we speak. So that is fixed, and then this needs to go here, and then I'll show you guys kind of like the hot mess that I'm doing, so you see what's going on. And then this one. All right, let's see. Oh, one thing too is sometimes if the microcontroller really starts to freak out, unplug it and replug it back in. See, like it took for a brief second. So I'm going to go ahead and just unplug this carefully. There we go. So this is now the code that I uploaded, and it's frozen with this code. So there's something funky going on, and it's been happening more and more with this microcontroller. So it might be on its way out where it just will not purge the old code. It'll like start to get all confused. So as it is doing now. But that does look cool. I'm not gonna lie. And then Dave Beck said, I thought I heard thunder. Yeah, no, I'm thinking I'm hearing some things in the background. It's not working because you're not wearing your safety glasses. Yep, that's probably true. It's always. And then Mick Perkins, your IQ must be over 150. You amaze me. No, this is why this is not working. My IQ is not over 150. So I'm just gonna like rest this here a second, or here, as I try and figure out why my amazing lighting design that I sat here and designed for you all is not working like at all. So all those are specified. This is specified. I closed every bracket because that tends to make it super angry when you don't close them brackets. Let's see. That's closed. And that's closed. Is that a semicolon or a colon? There we go. And let me save this. Check it. And then I think what I'll try and do too is, yeah, it just wants to keep that. So I'm going to try and just reset the whole thing by unplugging this microcontroller and unplugging the strip. There we go. And then it's always good to plug the strip in first and then the microcontroller. And you see that it's plugged in, but it's not doing anything because it's not getting any data to its data pin. So it's not till we plug in the microcontroller that it wakes up and it's still doing its funkiness. So I'm going to try and upload a different code here real quick to see if that kind of unstucks it. Let's see which one. I'll do the... we'll upload this test and see what happens. This is like something totally different. So, yes, there's a lot of hurry up and wait. This is, the strip is all acting crazy. And everything was going fine until I wonder if the power outage did something, because everything was plugged in. And that might have fritzed a couple things. But in any case... let me show you the inside of this thing and then we'll come back to this. I'm going to turn it off for a little bit and see if it kind of resets. Because that would be sad if my Arduino is beginning to fritz. Because everything is correct. It's the same code I've been using to test it all along. So I'm going to put the the laptop down and let's just have a quick look at how far I got and what the back of this thing looks like and where I kind of ran into problems when I went to position this thing for you. So Jealous, is there a green wire unhooked at the... Oh, I know what that is. So let me get rid of myself here for a second. Go away, Rachel. So this spaghetti here is our lightning detector. And the objective with the lightning detector is that you want to keep it away from as much electrical stuff as you can. Phones, appliances, anything like that, because it'll definitely interfere with it. So that's why I kind of jerry-rigged this temporary situation right here for us to be able to test this and be able to move it away from different things. The last time we put this together with the wrench army, and we found that having it close to my iPad, my phone, the computer was making it go nuts. And it was giving us all kinds of errors that it's great because it tells us it's working and it's working in the right way. So we were able to kind of move it around and find the best spot for it. Also configure a lot of the parameters to get it working just right. So that's what this is. And so the wire gel is talking about is this guy right here. So what is this here? This, along with these two right here, are the original wires that actually hook up to the real LEDs that are all running in here. So this is unhooked on purpose. And so what I did was hook up this spare LED. This is spare strip that I have left for, adding on to this project or maybe doing a whole other project. So I took this spare strip and I ran it on the inside, kind of like all crappy and stuff, and I hooked it up that way. So these are totally separate, don't have anything to do with each other. But I'm going to take a look here and just kind of carefully wiggle the wires around. And what I'm going to do is bust out the multimeter and see if I have any weird bridging. Now, normally if you get bridging, it doesn't work at all. But I'm going to put it in on its continuity setting. So... don't have it clicked just right. Oh, do you need batteries? This is like the stream where right before I hit go live, it's just been going like against me. Is there a reset button on the Arduino board? There is, and that did nothing. Nothing. So anyways, it clearly does not look bridged to me. I'm going to show you one that is bridged though. And on the back, and that was kind of where I moved it, and the wires must have just kind of touched a little bit and bridged. So I'm going to have to desolder it, unsolder it, just to give it a little bit more room and prevent that from happening again. So let me gently remove this strip right here. Oh no, my little clouds. That's okay. I'm still going to add a couple more clouds. I'm not too worried if they get too butchered. And I'm going to move this guy very carefully because I don't want to, get these, my finely soldered ends there. There we go. So let me show you what I did here. And this is kind of tough to see. That's as far back as we go, but we went ahead and made this frame together with our PVC piping that we used hot heat gun to bend into our shape. So that ended up, looking pretty nice. Now this, I'm just going to hold it in place. What I did was put a hinge on this side and a magnetic catch on this side. So when you open it, you might hear it click, just like that. And look, I can open it like a book and be able to remove the castle, which I'm going to Velcro into place. I didn't Mod Podge that well enough. Did you hear the little rocks falling? But I'm going to put a couple Velcro strips on this and then Velcro it down. I haven't done it yet because we still have to plumb our fog juice, our, fog machine that is going to be connected to this tower. Now, this tower has holes in it. It's dilapidated. Here's a giant crack coming down. And so it gives us a lot of areas for that smoke to billow out, and we'll control it with the Arduino to set it off every so often while the other lighting effect is going on. So I'm just going to kind of move this aside for now to show you guys what I got going on. So as you can see, I have an LED strip that goes all the way around to about here, and then, you know, all the way around to about here. Then it ducks down underneath the board and comes up on the other side. And that's where I'm going to flip this over and show you guys the hot mess that it is. So I made it such that I can remove this board. It's just a lot easier to flip it over. And with this book type of scenario, it makes it easy to kind of get in there and repair things, which obviously I'm having to do a lot of before the project is even done. So I'm just going to gently flip this over. It's not connected to anything. No. And let's see the best way to kind of show you guys. Since it's not really connected, I guess I can be kind of brutal with it, since I'm going to have to look at a lot of these. So for those of you that couldn't, you know, see it in the other view, that's pretty much our, you know, our frame here. And I thought it came out really nice. A little spackle did wonders. Makes it look like real stone. And I'm going to turn this around, and you guys can see that I put a little wire so we can hang it just like a picture frame. So I took that out of the way, and you can see the hot mess that this is. And in fact, it might look better if I just lay it down. There we go. Let's see what that looks like. All right, you guys can see most of it. I'm going to go ahead and just move this a little bit closer. There we go. So here's our little hanger, and you can see that our LED strip starts here. Now this you can plug into a, you know, controller or something like that. I might as well just like cut it off. But basically, here's our wires. This is our signal wire here, power and ground. This is the wire that Gel saw. See, it's all unconnected because I screwed this whole thing up right before the stream and pulled something here, and I found out where I pulled that disconnected. That's an exhaust, people. Did you hear that? Somebody fired up right outside my door. And then one is still looking for his bobcat. And then Jill said, it's not too bad at all. No, this was not very bad to solder. The more connection points you have, the more, you know, you introduce probability of something going wrong. But at the end of the day, it was just one problem area that I had with bridging, and then the rest was fine. So basically, this is where the signal is going to come in, and I'm going to move myself. So it's going to come in through here. Power and ground doesn't matter. I will probably end up putting more power and ground and feed it from the other side of the strip as well. That way we don't get so much voltage drop, and we can have just nice bright colors all the way to the end of our animation. And then, oh, I only had this tied together, so don't worry about it. Just for testing purposes. So the signal then travels down here, and this is our amber candle light. Right beside it is our spark. These are in Frankenstein's tower. Continuing on, here's another amber light, and this is for FB, you know, from her, you know. And here is for that tall, skinny tower. That's another amber light. It continues on, and we have our first thundercloud right here. And I'm gonna already see I gotta move myself. And then follows along to this thundercloud, and then it's gonna loop up and around to this thundercloud, and then we have thunderclouds here, and this is where you can see it's a hot mess. I already unsoldered or desoldered this LED right here. We had a bridge here, and we have these two are bridged, the signal wire and the power wire. So everything worked all the way up until this LED, and so I kind of have to fix these two LEDs, and then it was working before, so I'm gonna assume it works. And then Rick Francis saying, you'll get it fixed up, no problem. I certainly will. And then I want to restream this again for you guys, because right now this is just a tribute, and it's not going well even for a tribute. So it's a tribute of the tribute. Yeah. And then Jella saying, maybe wire the tie loose wires to keep them from snagging on stuff. Yes. So I've already started tacking with hot glue, so it's nice and firm. It also prevents it from pulling on the actual connections. So I used hot glue, and let me see, maybe I can give you guys a much better, there we go. You can see what's going on. So you'll notice that before and after each connection, I put hot glue. That way, if this tugs, it doesn't pull on it very much. And so every connection is pretty much like that. And then I'm going to back you guys on out just a little or a lot. And then so we got done with the thunderclouds here. And then it goes up to our lightning bolt over here. And so the lightning bolt is facing down, and I put this material here, and it's basically like if you're ever moving, I'll see if I have any like handy, but if you're ever moving and you use it to protect your plates and you put them in between your plates. So I have that folded over, so it's 2 layers. And the reason is the other stuff is hidden. The thunderclouds are hidden behind the cotton balls. The rest of this stuff is inside the castle. So you don't see the actual LED. You see like a nice reflection. The only thing that's different about that is the lightning bolt, because I did take a Dremel and Dremel out a shape of a lightning bolt. And I didn't want raw LEDs just kind of shining through it. I don't know. I thought it would make it look cheap. So I know that a lot of cosplayers use this material to diffuse LEDs. So I thought, heck, I might try it too. And it ended up looking really, really good. So that's basically what this is. And then I tacked down all the connections because they have to make a couple really tight turns and, 2 LEDs here. So this lightning bolt consists of all these different segments. And then once it gets down here, let's see if I move myself, then it goes through here, and this needs to be tacked down. I have like way too much extra here because I didn't know how much I would need. And this tucks in inside here, and then it pops out the other side, and that creates our sky lighting. So that's how everything is connected. And really the only area I had a problem is this little LED, which you guys totally can't see, but it's just this LED right here. So once that gets fixed up, we should be rocking. We should be rocking in no time. So I'm going to take these wires right here and hide them under here and try and turn on our situation and see if it turns on. Those hot glue holders are strain relief protection. Yes, exactly like what Dave was saying. So let's see if I can do this rather gracefully. All right. These in. So you can see that the thunderclouds were kind of in the earlier part of the LED strip when I was kind of still learning how to do this, how much heat to apply, all that kind of stuff. So figures the problem would be early on in the strip. And in order to find out where your problem is in the strip, say you do something like this and parts of it don't work, well, obviously, the next LED that's dead, that's where you want to look. But also the outgoing connection from the LED that's working, because it could be bridged right there. And so you replace the LED, you replace the connections on the one that's not working. But it turns out, like in my case, the problem was in the previous working LED, the outs, the power and the signal. They were just, they were getting to know each other a little too well, So I'm going to break it up. I'm going to be like a chaperone from the 1800s and just be like, no touching. So Steve Fulton is saying, make sure to track the time and let us know how long it takes to clean it up and solve. No, definitely will do. I'm hoping it's going to be on the short end because I know what the problem is. It's worse when you don't, and then you just start to kind of like poke around. But putting back my little castle here, put him back. Close the book. Needs to go a little bit higher. There we go. He's all happy there. And let's see if I can get this LED strip resting ever so gently back. Good eye gel, though. He definitely saw that green floating wire, and normally that's pretty much the case. That's what would happen. A lot these wires, like you guys have said, pop off really, really easy. So you do have to be super gentle. So a lot of it is just popped off because sometimes I'm impatient and I'm like getting the project together and all that, where I shouldn't be. I should be way more patient. So let me see if I can very gently bring this stuff back. And we can mess around with our lightning detector a little bit. But I wanted to give this one more go and see if we can get it working. No, don't get tangled. All right. Yeah, the connections are pretty good on this end. And they were working in the beginning. That code that I uploaded, the lightning code, was indeed how it was supposed to work. So it was working, but it was also the one that was loaded before the power outage. So I've noticed there are a couple wonky things going on with this project since that happened. So I'm hoping, you know, I can salvage it. I'm just grabbing the connections down here. Whoop. I'm back. All right, let's get this hooked up. And I'm going to hook up the power to the LEDs first. Come over here. And then Jill says, the first thing troubleshooting is to check all the connections, right? Indeed, yeah, one by one. Start with the first LED, and that's what I did because I figured the problem was going to be towards the beginning. Also, the thundercloud is a dead giveaway, but because, you know, you get better and better as you solder more of these LEDs. So that's interesting. Yeah, so I'm wondering if the power surge did something kind of funky. I hope it didn't ruin my lightning. And I'm going to go ahead and just for fun hit that reset button right here. Nope, it did not like that. It said, I am freaking out. It's like trying to do the lightning thing that I programmed, but it's using all kinds of different colors. So it could be that mayhaps I fried something, which is good. It might be like fortuitous that this thing broke right before this stream because it wasn't affected by the power outage. It was completely unhooked. So I'm wondering if that's kind of like all this happened for a reason because it would have been this. And can you imagine replacing, potentially LEDs? Obviously, I think the LEDs work. I think it's the microcontroller. So I'm going to steal the one off of Farticus and use it here because it's been kind of sitting there. Once I identified my culprit, which was Eeyore, I haven't really used it all that much. So let's see. All I'm going to do is lightning scenes test. Why don't we just turn it all like blue or something? You know, why have it a whole bunch of colors? So I'm just going to turn it blue. Oh, this is the wrong code. Oops. Let me, but still the other should have worked as well. So that doesn't even solve the problem. So this is a new lighting theme. So this one works. So basically when lightning is happening, I just wrote this quick, it randomizes the brightness, that dimmer switch. So every time it runs, it picks a different brightness. And so it just kind of goes nuts. So the sky will be doing this. The lightning bolt, of course, is going to be on like solid, like a crash. But this is the sky motif of what's going to be going on. So let's see here for this one. Yeah, it does not like this sketch for whatever reason. But the interesting thing is that it is definitely cycling through some rainbows. So it's like it wants to do it, but it's just not doing it. I take this out. There we go. So what I'm going to do is just swap microcontrollers for us for the next stream. I did some troubleshooting though with you guys, which is nice. So yes, this stream was like doomed from the beginning, it looks like. It all started when I went to move it and disconnected something, but that might have been fortuitous because I probably saved us from the lightning, you know, the lightning storm that took out our power. That seems to be affecting a couple things. This is not the only weird thing going on here in the shop since that happened. So I'm thinking certain things are awry, or we have Frankenstein ghosts and other paranormal stuff going on here. So David Beck saying missing a semicolon. Yeah, that's the first thing I looked at, you know, because semicolons are super, super easy to miss. So looking at it, and I'm going to work on getting this laptop just situated, live streamed as well, so that way you guys can watch this stuff too, you know, instead of like I'm all here doing my thing. And let me check all the ends, make sure the semicolons are all happening. They're happy, just like Bob Ross, a happy little semicolon, a happy semicolon. And the nice thing is usually when you verify the code, the Arduino program will tell you, hey, you know, you're screwing something up right here, you know, so fix it. And so what if I do something like, oh, the other thing is I wonder if there's not enough LEDs in the strip and it's confused. So I'm gonna back this number down to 60 total LEDs. That might be causing some things where it's just like, wait a minute, you are just trying to have too many LEDs. And I'll have to call this one 50A and see if it likes that better. No. And that's funny because like this part is doing what I want it to do, but this part isn't. So I'm wondering if like a part of it is just whacked out. So what I'm gonna do is go back through all my code, which was working, you know, 2 hours ago, and all of a sudden it decides not to, but that's probably because all this was plugged in. Wow, the lightning. That's the only oddball thing here. So I'm going to try my other microcontroller, which is in a place that's kind of tough to get to, or else I'd get it now and swap it out right now and see how that works. But in the meantime, let's check out this lightning detector really quick. And then I'll be back at you guys for, you know, for fixing this. You know, and then we'll schedule a stream to just finally not do the tribute of the tribute or the tribute, but the actual real thing. So I'm going to meet you guys over at the computer. 1 sec. All right, so let me pull up we looked at like what it's supposed to be doing, you know, when there's no lightning. And that is the nice interior lighting, the little spark that comes up, and also that sky, you know, kind of U-shaped thing, just kind of cycles through all the colors of the rainbow. Not in a freak out manner that it's doing right now, but in a calm, very Bob Rossian manner, all right? So let's see here with the lightning, our lightning scene, and I'm just gonna switch the screen for me here. And nope, not that one, this one. All right, so this is so I have these sketches all separate and they are not tied to the lightning detector. So actually, let's look at the one that is tied to the lightning detector, which is this one right here. And let me get it up like I have it up for you guys. Now I'm gonna get it up for me as well. All right, so looking at this, and I'm gonna bump up the font. Let's see what the font is. Okay, it's 24, it's pretty good. All right. if I needed any more, then I need to up this, put the big old Coke bottle ones on. And so Dave Beck saying tribute intermissions. Jell is saying that those strips are very delicate. And yes, they are. And Jell said, did you say this program worked before? Indeed it did. So it was literally working right up until 10 minutes before we were going to stream. And so I had the computer on. I got 10 minutes till I hit start streaming. And also this strip was connected. I went through all the programs because I had to load them onto here for you guys to see. So yes, it was literally working. And so it's sitting in the computer. There was no chance for, anyone to really mess with it. So it's the same that you're seeing here. So yes, I'm not quite sure. And so the only thing that happened that's out of the ordinary is the storm that we were having that shut down the power to the entire house. So I was like, uh-oh, how am I going to tell you guys there's no stream? I had my phone and I'm like, if it doesn't come on by like 5:25, I'm going to have to cancel the stream. But it came on. And then it just reloaded the sequence that it was on, which was that not colorful, but the whites going all crazy and things. So yeah, it's having trouble accepting new programs, it seems. But I'll continue troubleshooting and trying to, figure out what it is. So going through this, this also includes the lightning detector code. And so here we're just including an SPI library, which is how it works. SparkFun is the company that I bought the lightning detector from. It uses this chip right here. And so a lot of lightning detectors use this chip. It's a popular chip. So you can buy pretty much any brand. This one I found on Amazon as I was ordering other things. So I'm like, heck, might as well throw it into the cart. And this was a time where we were going to make a lightning detector pocket lightning detector, so we could make it out of leather, something kind of cool. I even bought a little LCD screen for it and it turned into this. So yes, maybe this is not so convenient to be running down the field trying to detect lightning and stuff, but really cool display, more than a handheld lightning detector. So I like where this project went. This was like your guys' idea. Anyways, the fast LED library, so we already talked about that. So then the lightning detector needs to know different things. And this already came with the lightning detector. You can change some of these parameters. They worked for our instance here in this garage. And then we're just defining a couple things. We went through this in super depth. That's why I'm kind of moving through it. This was our very first stream for Wrench Army members. And so here, it just wants to know, where are you connecting the interrupt pin for the lightning detector? That's probably the most important pin. They're all important, but this is the most important one because this is the one that really looks for that lightning or tells you when there's lightning. So that's connected to pin number 4. And then this is connected to pin number 10, the SPI chip select. Now, if you have different lightning detectors, you'll specify different things, but this is a really good little library that gives you all kinds of examples where you can literally upload the example and you're ready to start detecting lightning. It's really great. Here, you can set different variables for noise. So say an environment like this, noise is just that constant electrical interference. So computers, cell phones, when you have your lightning detector, you want to make sure that you don't have it near the microcontroller because the microcontroller itself will emit noise. And so noise is that constant. And so what you can do here is if you're having a lot of trouble with noise and you just can't get the lightning detector anywhere away because you're using it indoors, is you can set this noise higher. So it'll start to raise the barrier and the noise is kind of down here. But there's always, a trade-off. So it's going to be a little bit less sensitive every time you bump up that noise. So 1 has always worked in here, especially when we got the lightning detector away from these computers and the phone. It worked pretty well. Now a disturber is a lot like noise, but it's a one-time thing. It's like a one strike. And so it mimics a lightning strike, but the lightning detector is like, nice try, that's not lightning. So it'll warn you that there's a disturber going on. So you can even take a barbecue lighter and put 2 of them and just start really clicking on them, and that should set off a disturber. So here again, if you're getting a lot of disturbers, you can vary this number, set it from 1 to 10, and do it that way. And the default is 2. Now again, same thing as a trade-off. The more you set it higher, the less sensitive it is. So here, we go back to talking about our LEDs. We have 110 LEDs. They're on pin number 2. So then getting in here, basically, you have your input, which is your lightning interrupt on pin number 4. And so when it begins, we can open up the serial monitor here, which is like this right here, and it'll tell us verbally or in text form what's going on. And this really helps you troubleshoot what's going on with your lightning detector, because normally, unless it's hooked up to an LED or some type of like indicator to tell you it's working, you won't know. So you can send the results to an LCD screen, exactly like we were going to do, but the Arduino software program has a built-in little window that shows you what's going on. So that's pretty much what that is. And here it's just a condition that if it didn't start up and it's freezing, it'll let you know in this little window. Or, so if and then or else, then it means it's working. And so the lightning detector is ready to start detecting. Here are a couple more LED things that we've already seen. And so here's we start our loop. This is the part that repeats itself over and over again. And I just keep looking at your comments, and Jill saying possibly the strip went bad. That might be because it seems to want to be working on one side, but this kind of starter side isn't. There's some kind of weirdness going on. So I'm gonna start to troubleshooting, but first I'm gonna fix that LED that I know is the problem, because then I'll be able to hook the Arduino to the actual window and bypass this whole strip situation, and maybe the microcontroller is good. So we'll see. Here is, of course, the way we're gonna start our scene. So nice little candles going in the laboratory, in FB's tower, and also in that big skinny kind of castle-like tower. So we have 3 flickering candles going on in the premises. Here we have our spark, and so it's 160, it's blue, and every 5 seconds it changes in intensity of brightness. It's always blue, but it's going to change in intensity. And here we're going to fill the rainbow part of this strip, which is the sky, in a rainbow. And the rainbow is going to go from like red to green to blue. I guess that's not really rainbow order, but you know what I mean. Red, orange, yellow, and cycle through numbers 0 through 255. So all those colors, not just red, but the in-betweens of reds, yellow going to orange, all that kind of stuff. So that's what's going to be going on if there's no lightning. So here's where the lightning detector part starts. So here it's saying that if the pin goes high, meaning, there's input coming in, and the detector decides that it's noise, then it's going to print noise. Now, of course, you can print this to an LCD screen or in this little monitor thingy right here, which it's giving me an error down here because I don't have the board connected to this computer. So it's like, I can't find your board, so how can I know what's going on? So here it even tells you hey, too much noise, uncomment the line below, and then remember that numbers up top, go make that number higher. And so here I can just remove this and see how it even changes color. Now it's going to read this, and whatever number that we put up there, it's going to use kind of in this parentheses right here. And so, for us, I know that it works out of the box pretty default. We really didn't have to do anything. We played with a couple values, but found that that was the case. And I thought, wouldn't it be nice to have a visual cue if we're getting too much noise? Say I hang the window in a place where I just get too much electrical noise and it's not going to work anyways. So the visual cue here is that 64, this is a very nice kind of yellowish color. And again, it goes crazy with the dimmer switch. And so it just kind of twinkles yellow, goes crazy yellow. So if I see that, then I know we're getting noise and I need to move the picture frame, or leave the picture frame, but move the lightning detector somewhere where it can read a little bit more reliably. So that's a visual cue that we have. Here, so you'll see if, else if. So if that's not the case, let's check out this case. If it's a disturber, then I have it going, what's the color here? Red. 0 is red. So if it's a disturber, then the whole thing twinkles red. It's like, oh my gosh, and it's going to twinkle really quick because a disturber is just that one thing that's trying to fake itself into lightning, but it's not. So if I have a lot of that going on, again, you want to try and move that lightning detector or set the values above to kind of cancel some of that stuff out. So here, finally, we've gone to noise, disturbers. Where's the lightning, right? So here's the lightning part. So if it's neither one of those two cases, well, then we gotta have lightning, right? So if the internal formulas and algorithms of the lightning detector, and there's a whole write-up on, you can learn how it works and how it determines lightning from non-lightning. So if it is lightning, here your little window, if we had it open, would say lightning strike detected, and it'll even tell you about how far away it is in kilometers. So for our purposes, eventually I want to put a LCD screen or some kind of indicator. Maybe it's a light bar that lights the distance of the storm, and we can put that in our control panel. So as soon as we have the light situation figured out, we have our control panel up, where I'm going to use this cool little knife switch right here to turn the whole thing on. We're pretty much going to call it a day on this project, but the project is going to make cameos in future streams while we're working on a totally different project as we continue adding to it, like temperature gauges, barometric pressure, humidity, and all of these can have different lighting schemes to let us know. We can make it really red on hot days, you know, and really like almost white frigid on cold days. So you can do a lot of things with indicators and not have to get a LCD screen, but knowing the exact temperature is kind of helpful. So we'll do that. And so here, the lighting is going to just flash really crazy. So here, these LEDs right here are, here's the lightning bolt. Oh, the thunderclouds. So see how I have it aptly named there, and I'm not even looking at my own notes. So here are all the thunderclouds that are just gonna like go off like crazy. And then our lightning bolt, which is LEDs 10 through 39, that is gonna light white. Now you'll see 160 and you're like, wait a minute, that is blue. Well, there's no real good way to do white with HSV. The best way to do it is you can put it any color you want. It doesn't matter. But if you take away all the color pigmentation, it turns white. So that's what the 0 is here for. We turned all that color pigmentation down, and we set the brightness to full. Unlike here where we have the brightness kind of randomly like the thunderclouds, this is gonna like come on and be like in your face. And then also our rainbow, the sky here. I keep calling it the rainbow because the LEDs are arranged in an arc, kind of like a rainbow. So what I mean is the sky. So for here, it's going to do the same thing with white. You can see the 0. I took the blue and I desaturated all the way to 0, which makes it white. But the lightness darkness, meaning that dimmer switch, is going to go crazy. And that's what this random 8 is. It's just going to go random. And so you have thunderclouds going, you have the sky going, and then you got that like big thunderbolt, lightning bolt coming up out of the sky, and you'll notice its placement. It was hitting Frankenstein's castle right in the laboratory section, and that was like on purpose. And then here, this delay just means stop everything for 100 milliseconds and then reset the searching of the lightning. So that's pretty much the code that we're going to finally upload, test, and use once I get all this stuff working. This is like the accursed stream. So I'm gonna go back to the other side and I'll meet you guys there. All right, so we got audio. Yes, we do. So Jealous saying, don't use as a safety device. You will be dead before you see the alert. That is so true. This is a decorative lightning detector. In no means like would I put this, say, in a barn or an area where lightning is more of a life-threatening problem and use this to detect the lightning. You're going to be done, especially since right now we don't even have a mechanism on how to tell you how far the lightning is. I even thought about using this blank space right here and maybe putting building a cool maybe wooden box or something that has an LED strip that lights the number of kilometers that's away. So that's, part of the code that we're going to add on to. And I have some dead pixels. So Gel might be right. I think this strip might be toast. So what I'm going to do later tonight is just connect this microcontroller back to the actual board LEDs here, because I know that part of it lights up. So I'll be able to see if at least that part of the sequence is working correctly. So we went through some code. We tried this out. The lightning, it's so apropos that we are doing a lightning project, and it's the lightning that got us here in the end. But I hope you guys, despite all this, enjoyed the tribute of the actual lighting scene, which we'll be doing soon here in a bit. I'm just going to troubleshoot this between today and tomorrow, and we should be back on track to watch this thing really work. And I'm not too worried because we have a ton of storms coming. We have them just about every day now, getting into late summer. So Dave Beck says, new follower a few minutes ago. Oh my gosh, I missed our new follower. Well, welcome. That's probably from Twitch. And yes, not the most convenient to be running around with this window outside with battery packs of figuring out, if you have lightning or not. But all in all, I think it's going to look cool. Here's our lightning that's going to come down. It's going to hit our Frankenstein castle. And I also have lightning hitting our little tower right there. So this looked really good. You guys had a ton of great ideas here, and it turned out amazing. So I got some troubleshooting to do, and I will see you guys next time. Stay tuned to the schedule. I'm always posting it on social media, but Discord is the best way to see when I'm streaming, because not all of you guys get the social media updates, because the algorithms, they always like to jack things up. So Discord's the best way. There's a link to Discord in the YouTube video description. It's also a Twitch panel, and on Facebook, I believe in the description, there's also a little link to Discord. It is free. Sign up there. It's like a fast-moving live chat forum. So Carl James says, stay safe and check that part number. I will. I need a flux capacitor. And Brian Palmer, I like that. Very cool. Thanks, Rachel. So I'll see you guys next time. Bye.